Hi guys, you are welcome to Linear Stereo College class. And the next question I will have here is find the polynomial of second degree to approximate f of x at x naught equals to 0 if f of x is equals to ln 1 plus x. Don't forget that this particular topic is Taylor series, then the formula we're going to use is Maclaurin series. So I'm using Maclaurin series because we are asked to expand the function at x naught equals to 0. So to obtain a polynomial of second degree, so let's go to the solution. And the first thing, we'll write the formula. That's p of x is equals to f of 0 plus x f prime of 0 plus x square f prime prime of 0 then over 2 factorial. So that's the formula we'll use to solve the particular question, this particular problem. And don't forget that f of x is equals to ln 1 plus x. And from the formula that we have there, we are to obtain f prime of 0, then f prime prime of 0. So now to obtain f prime of 0, the first thing I will need to do is to obtain f prime of x. And to obtain f prime of x here is, we have a logarithmic function. This one is ln 1 plus x. We'll differentiate what we have there. Differentiating 1 will give us 0. Now differentiating x with respect to x, that will give us 1. So that will be over 1 plus x. So now when you differentiate x, that will give us 0, 1. By the time you differentiate 1, that will give us 0 because this 1 is a constant. Then plus differentiating x, that will give us 1 over 1 plus x. So now f prime of x is 1 over 1 plus x. We can also rewrite this as 1 plus x raised power negative 1, or we can say x plus 1 raised power negative 1. 1 over 1 plus x is something as 1 plus x raised power minus 1, or x plus 1 raised power negative 1. So now differentiating the second time, so that will make the second differential easier. So to differentiate the second time, f prime prime of x, instead of differentiating this using quotient rule, then we can actually go to this using chain rule. So we differentiate, we'll bring down the power there is minus 1. Now differentiate x, that will give us 1, use it to multiply this. Now differentiate this plus 1, that's a constant, that will give us 0. Then we open a bracket, x plus 1 raised power negative 1, negative 1. So now differentiating a function like this, the second time, so that will be the negative power, the power will come down, which is negative 1 times, differentiate what we have inside the bracket, that will give us 1. Then open a bracket, the whole function s plus 1, then raise power this negative 1, then we subtract 1 from the power as well. So that means from here we're going to have minus, open bracket, x plus 1 raised power negative 2. So we can also rewrite it as f prime prime of x can also be written as negative 1 over x plus 1 raised power of 2. With this x plus 1 raised power minus 2 that we have there, we can write it as 1 over x plus 1 raised power of 2. And this negative sign that we have here will come to this particular place. So now the next thing to do, don't forget that we have to expand it at point x equals to 0. So at the point x not equals to 0. So now f of 0 will give us, we'll go to this particular place. That's ln 1 plus 0 equals to ln 1. And ln 1 is equals to 0. So you can check that one from your calculator. Now f prime of 0, that will give us this our f prime of 0, which is 1 over 1 plus s, or we can write it as 1 plus this one. So let's say we have 1 over 1 plus 0, that's 1 over 1, which is equals to 1. And the next one is f prime prime of 0. And we'll go to this f prime prime of x. Wherever we see x, we change it to 0. So that will give us negative 1 over 1 plus 0 raised power of 2 equals to negative 1 over 1 raised power of 2. So now f prime prime of 0 will give us negative 1 over 1 raised power 2, that's 1 times 1, which will give us 1. So minus 1 over 1 will give us negative 1. So now, using this particular formula that we have here, this is the formula that we are using this particular formula. So that means ln 1 plus x is equals to, f of 0 actually give us 0, then plus x is here, open a bracket, f prime of 0, the value of that one is 1, then plus, here we have s square in brackets, f prime prime of 0 actually give us negative 1 over 2 factorial. And don't forget that 2 factorial is 2 times 1, which is what? 2. So therefore, ln 1 plus x is equals to x minus x squared over 2. Or we can find the LCM and say we have 2x minus x squared over 2. So it's still the same thing, because x times 1 will give us x squared times minus 1 will give us minus x squared, then 2 factorial will give us 2. Kindly drop your comments, like and share the video, then kindly follow for more.